Samsung has just started mass production of its newest SSD built for AI servers. If you're thinking, an SSD? That's the same thing that's already sitting in my PC, nothing new here. Then today's video is exactly the one for you. An SSD made for an AI server is in a completely different class from the one in your PC. And in the world of AI servers, everyone keeps their eyes fixed on the GPU. But the way I read it, storage is about to become one of the real battlegrounds.
Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today, using Samsung's newly mass-produced SSD, the PM1763, as our entry point, I'll walk you through how server SSDs actually differ from PC SSDs and why storage becomes so important in the age of AI. By the end of this video, you'll be able to read AI server news from an angle that goes beyond just the GPU. As always, let me start with a familiar analogy. Here's today's news in one picture, and we'll lean on this restaurant and chef analogy all the way through the opening section. The stage is the restaurant of a top-tier luxury hotel. The stars of this restaurant are without question its highly skilled chefs. Customers and the media alike always fix their attention on the chef's dazzling knife work, and it's always the chefs who get the magazine feature spreads. Recently, though, something strange happened in this restaurant. The chef's skills shot up dramatically, and their cooking speed became faster by an order of magnitude. And that surfaced an unexpected problem. The speed of pulling ingredients out of the refrigerators and getting them to the chefs simply couldn't keep up. No matter how fast the chefs are, if the ingredients don't arrive, their hands come to a stop. You might think, well then, just line up a whole lot of household refrigerators. But that doesn't work. A household refrigerator is built on the assumption that you'll open its door a few times a day. In this kitchen, by contrast, ingredients are pulled in and out non-stop, 24 hours a day, 365 days a year, never allowed to pause for even a moment. The very class of performance being demanded is fundamentally different. What's more, a large kitchen has dozens of refrigerators lined up. The more units you have, the higher the odds that one of them breaks down, and a single failure can bring the entire kitchen to a halt. On top of that, because they're used in a way that swaps out huge volumes of ingredients wholesale every single day, the doors and shelves wear out many times faster than normal. Not breaking down and not wearing out, that matters just as much as speed. This is where the professional, industrial-grade cold storage room comes in. Retrieval is faster by an order of magnitude. Its parts are carefully hand-picked, it withstands a complete turnover of its contents every day, and it's designed as one integrated system together with the kitchen's entire cooling setup. It may look like the same box that keeps things cold, but inside, it's an entirely different thing. From here, let me walk you through what this actually looks like in the real semiconductor industry. Today's main character is Samsung. It's a comprehensive semiconductor maker from South Korea and one of the world's leaders in memory chips. On July 8, 2026, Samsung announced the start of mass production of the PM1763, an enterprise SSD for AI servers and HPC, that is, high-performance computing. Enterprise means for corporate servers, and it's a completely different category of product from the PC SSDs we pick up at an electronics store. Let's look inside the PM1763. For the data pathway, it adopts the latest standard, PCIe 6.0. For the memory element, it uses 9th generation VNAND, and the controller that governs the whole thing is built on a cutting-edge 4-nanometer process. The data pathway, the memory element, and the brain, every single component that makes up an SSD has been locked in at the newest generation. Let's also take a look at the performance numbers. On the 16 terabyte model, sequential read reaches up to 28.4 gigabytes per second, and write up to 21.9 gigabytes per second. That's fast enough to load a large language model of around 40 gigabytes in about 1.4 seconds. In other words, you can call up the model that serves as the AI's brain in an instant. And its power efficiency has improved by more than 1.8 times compared with the previous generation. It comes in 3 capacity models: 4, 8, and 16 terabytes. It also supports post-quantum cryptography to guard against future decryption by quantum computers, along with a security standard called TDSP. And one more thing worth noting is that it's optimized for direct-to-chip, or D2C, liquid-cooled servers, the kind that cool the chip directly with liquid. From here, let me dig in from a professional's perspective. The general press tends to focus on that speed figure, 28.4 gigabytes per second. But what I really want you to look at isn't the speed itself, it's the substance behind what I said at the start, that a server SSD is in a different class from a PC SSD. There are 4 major differences. Let's go through them one by one. The first is the controller, the brain of the SSD. Error-correcting ECC, the FTL that manages where data is placed, and the control of data transfer. All of this has to be handled at high speed and low power. And in the PM1763, Samsung has poured a cutting-edge 4-nanometer process into this brain. Spending this much, not just on the memory element, but on the brain as well, that is the world of server SSDs. The second is reliability. It's common for an AI server to carry more than 20 SSDs. The more units there are, the more the odds of any single one of them failing pile up. That's exactly why each and every drive demands strict quality screening, powerful error correction, long-term firmware verification, and power loss protection that safeguards data when the power cuts out. It's the same structure as our analogy, a single failure bringing the whole kitchen to a stop. The third is endurance. The metric here is called DWPD, a number that expresses how many times a day you're allowed to rewrite the SSD's entire capacity. For PC drives, it's around 0.3, but for enterprise drives, it's 1 to 3. If we take a 16 terabyte drive at 3 DWPD, the math works out to 48 terabytes of writes guaranteed every day. In AI training, saving intermediate progress and logging generate huge volumes of writes, so this endurance really comes into play. The fourth is cooling. In AI servers, liquid cooling of the GPU and CPU is advancing fast, and we're entering an era where the SSD, too, is designed on the premise of liquid cooling. Behind this, the way I see it, is a picture in which the GPU's performance is improving so quickly that the storage side feeding it data is becoming the bottleneck. The star of the kitchen got faster, so now the build of the cold storage room is called into question. It's exactly as the analogy suggested. In other words, the competition in NAND memory is no longer settled by generations of the memory element alone. My read is that it's shifting toward a competition of total capability, one that takes in the memory element, the controller, the firmware, the security, and even the cooling support. The question is whether you can design the drive not as a standalone part, but as one piece of the larger system that is the AI server. Now the impact on Japan. Japan, too, has makers working on NAND flash memory, so this competition of total capability is by no means someone else's problem. Beyond that, the way I see it, the spread of liquid-cooled servers could become a tailwind for Japanese companies working on cooling components, thermal management materials, and the related equipment. Liquid cooling is a movement that changes the design of the entire server, so the range of technologies it touches should be broad. Let me pull this together. When we talk about AI servers, the GPU always gets treated as the star, but without fast, reliable storage, AI simply won't run. NAND for AI servers is in a different class from NAND for PCs. That's the one line I'd like you to take home today. Look not only at the chefs, but also at the cold storage room. This perspective, I believe, is the key to reading semiconductor news in the age of AI. Let me summarize. On July 8, 2026, Samsung announced the start of mass production of the PM1763, a PCIe 6.0 enterprise SSD. On the 16 terabyte model, read speed reaches up to 28.4 gigabytes per second, fast enough to load a large language model of around 40 gigabytes in about 1.4 seconds. But the real point of interest is not the speed, it's the engineering, the controller, the reliability, the endurance, and the liquid cooling support.
all on a level entirely different from PC drives. The competition in NAND is entering the age of total capability.
That's all for today. I'll keep bringing you semiconductor news and analysis. So if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.